Hey everybody, Dr. O here. And on this chart, I've created a way for you to organize the information around the adrenal gland. And the reason why I've done this is that the adrenal gland can be rather complex. It has a variety of zones. Each zone releases a class of hormone, and within those classes of hormones, there's at least one that we want you to know about. And then each zone gets stimulated by a different type of stimulus, and we want you to know specifically what stimulus is triggering the release of the hormones that we want you to know about. So let's start off by labeling the zones. And the first thing I want to point out is that up here at the top is our outer layer, and we're working towards the inner layer. So we're moving towards the interior. These first three zones are what we're going to find in the cortex. And then the inner zone, this fourth zone, is going to be the medulla. So what we're going to fill in here is going to be the medullas, but we do have individual names for these upper three zones. So let's go ahead and fill those in. So the outer zone is known as the zona glomerulosa. The next outer zone, or the next one moving towards the interior, is the zona fasciculata. The zone that is deep to that is known as the zona reticularis. And as I said just a moment ago, this innermost layer is just simply known as the adrenal medulla. Now let's talk about the hormones that get released from each of these four zones. And we're going to label both the general classification of the hormones that get released from these zones, as well as a specific hormone that we want you to know about. So from the zona glomerulosa, the classification of hormones that are being released are the mineralocorticoids. And the one that we want you to know about is aldosterone. Now the reason why these are called mineralocorticoids is because what they're moving around are minerals. So in the case of aldosterone, aldosterone is moving sodium around out of the kidneys, knowing that water will follow. So it's actually a water management system. That's what aldosterone is. So we could think of aldosterone as moving salt around for the purpose of moving water around in the body. So we could just kind of hang our hats on salt right there. Now the zona fasciculata is releasing a class of hormones known as glucocorticoids. And the one that we want you to know about is cortisol. Now the name gluco tells us that it has something to do with sugar. And indeed what cortisol does is that it triggers the body to ensure that there are robust levels of blood glucose floating around in the body, because the body will need that in times of stress. So this is when cortisol gets released, in times of stress, when the body needs plenty of glucose released so that it will have that available for the cells to make ATP. Now from the zona reticularis, we are releasing a classification of molecule known as the gonadotropins, and the one that we want you to know about is androgen. Now androgen is a precursor molecule to testosterone, and what testosterone is going to be doing in both males and females, because this gets released in both males and females, is going to be driving libido. It'll be doing some other things, but we can generally say it's driving libido. So we could think of this one as sex. So most people can correlate some understanding with salt, sugar, sex. So I like to throw that out there to help you remember these classification of hormones. Now the adrenal medulla is going to be releasing epinephrine and norepinephrine. These are also our stress hormones. They get released during times of fight or flight. Now let's talk about the stimulus for the release of each of these hormones, starting with the mineralocorticoid, specifically aldosterone. Now the type of stimulus that's going to trigger the release of aldosterone is something known as a hormonal release. And the hormone that's going to trigger the release of aldosterone is a hormone known as angiotensin II. The type of stimulus that's going to trigger the release of a glucocorticoid, this is also a hormonal stimulation, and specifically ACTH coming from the anterior pituitary is going to trigger the release of cortisol. Regarding androgen, the same thing is true here. It's going to be a hormonal stimulation, specifically the hormone ACTH, which is released by the anterior pituitary. So ACTH will trigger the release of cortisol and androgen. Now, what's going to trigger the release of epinephrine? This is a neural stimulus, and specifically it is neural input from the sympathetic nervous system, because remember, our sympathetic nervous system is our fight or flight nervous system, and the hormones that it's going to trigger to be released from the adrenal medulla are going to be the epinephrine and norepinephrine. All right, I've got one more thing. That's right, I threw a little something else in on this video. So the thing that we also need to know about is that what type of hormones all these are. So some of these are steroid hormones. And I'll tell you this, it is the hormones of the cortex that are going to be our steroid hormones. So that means that the zona glomerulosa, the zona fasciculata, the zona reticularis, and the hormones that are being released, these are all our steroid hormones. Now, what's the thing about steroid hormones? Well, the big thing here is to know that they're fat-based. And once they get to the plasma membrane, they're going to be able to slip right past that plasma membrane and lodge onto a receptor that is on the inside of the cell. So steroid hormones are going to be seeking an intracellular receptor. Now, what about the adrenal medulla and epinephrine and norepinephrine? These are going to be amino acid-based hormones. And because of this, they will not be able to slip past the cell membrane. So their receptors are going to be on the outside. They are going to be engaging with extracellular receptors. All right, so if you get to watch the video, then you got that little extra something as a result. All right, I hope you find this helpful, and I'll see you in the next one.